Hello there, I'm Dominique St-Pierre, and you're listening to Go Podcast. Today, I'm talking with John Arundel on cryptography. So hello golfers, I have a guest this week and I'm receiving John Arundel. So thank you very much for joining this podcast, John.
Thanks very much for having me.
So I like to start by asking guests what are their background and with a little bit bias towards Go. So I mean, obviously with the experience that you are having, let's try to keep it short. I guess you have a lot of things to say, but for people, how would you describe yourself?
Yeah, well, I usually say I'm a writer, and if people are still listening, I say I'm also a mentor. And they say, "What's that?" And I say, "It's like teaching, but slightly less boring."
Nice. Yeah.
So anyway.
Yeah. So that I like that a lot. So are you writing for a long time?
Yeah, I write Go books basically, or that's mostly what I'm interested in, and also a bit about careers, tech careers, how to survive in the tech industry. I mean, I have more or less so far. So hopefully, I've got some useful insights or tips for people who are getting into the industry now, and also maybe a bit further on in their careers, wondering how to survive it.
That's interesting. So I cannot I cannot not said something about AI. Is it something that you feel is starting to take a little bit of concerns, or I'm not sure how to explain that exactly, but are you seeing that as being more and more a concerns?
Yeah, definitely. Everybody's really concerned about it, aren't they? It's my students are asking me this as well, saying, is it even worth continuing with the mentoring? Is it worth me continuing learning to be a programmer if those jobs just aren't going to be there? Is Devin going to be doing it all? And my answer is sort of, well, I hope programming is still going to be an economically rewarding activity, because that's basically the only thing I'm any good at, apart from writing. And maybe books on programming won't be much use either, if nobody's interested in doing it. But I think they will be. Programming is fun, or it is if you're doing it right. That's my thesis. And that's what I try and teach people to do, is sort of have fun programming and do it the right way. The trouble is, maybe you need to get paid for something else, right? So you can do your programming in your spare time.
Yeah, sure. Well, I mean, yeah, this is something that kind of stood out when I kind of started to look at your profile and whatnot. The word fun that you are keeping saying across is something that resonates a lot with me. So this is exactly why I'm doing that. This is exactly why I kind of left my day job in 2007 to start my own company. It's not like day job or boring or whatnot, but the specific one that I was doing was not very fun. So I do that for those reasons, and the small amount of time that I've used AI, because I tried Copilot for 1 month. There's a 1 month free trial, and I told my wife something like, you know what? I feel like I am the machine now, and I don't like that at all.
Yeah, I know exactly what you mean. And I think it's really interesting to see what things like Copilot can do and can't do, or what it's good at. Working with students, often, usually pairing with them, writing some program, and a lot of them use Copilot, and I'll say to them, what should we do? Add some method here, load the data, and they'll start typing it, and Copilot basically just fills it out. And they're sort of like, oh, sorry about that. I'm accidentally cheating by using Copilot. And I'm kind of like, there's no cheating. I just think it's like, it's like your IDE. If you have a refactoring function or something, use it. Why not? What's the point of doing things the long way around? If it saves you a bunch of typing, why not? The point is it typing the right things for you? That's the question, isn't it?
Yeah. Oh yeah.
I don't think AI can answer that yet. I mean, it does its best to know what it thinks you want, but it's not always right. And actually, the really interesting thing about software engineering, I think, I don't know how you feel, is wanting the right stuff. What should your product do? How should the program act? What do users want it to do? What's an elegant design? This kind of thing. That's the really hard part, and that's the bit I have fun with. Writing the code to implement that is kind of the easy bit.
Yeah, understanding the goal of a system. I hear you on that for sure. Yeah, but on the other hand, for me, I mean, it's so fun when you have some kind of problem to solve at some point and you don't have the answer right away. The amount of joy that I have when I finally get out of my frustration of searching for a solution and completing it myself. This to me is something that I'm not sure I'm able to let go. This feeling of accomplishment.
I agree completely. It's fun for me, and often as a consultant, I would say to people, client would have some problem, and I'd say, why don't we write a program to solve this? And they'd say, oh, that's a good idea, but actually we just found this software that solves it already, so we'll just use that. I always feel really disappointed because I was like, we were going to write some software. Now we're just buying somebody else's product as a service. That's a shame. I mean, obviously it's great for the client, solves their problem, and it's probably more cost effective. But I just like programming stuff. Sorry about that.
Yeah, totally. I hear you on that for sure. I mean, but yeah, and when I see things like, I don't know if you saw that, but it's making a lot of noise in the last couple of days, especially on Twitter, the Devon thing. I'm not, I haven't checked that a lot so far, but I mean, it seems to be, I can understand that if I put me in the shoes of a younger developer, let's say I'm, I don't know, 18, 20 years old, I fully understand because my kids are like that as well. They are not in the software engineering and whatnot, but they are still concerned about that, even though they don't really know what they are going to do. It's still it's on them. It's more on them than on us. I mean us, bigger us, younger, older people. But I feel bad there a little bit for the young people.
Yeah, I do too, and I think. I was listening to your interview with Chris Shepard a while ago about gRPC and things, and you guys were talking about frameworks, and I think you both agreed. One thing about Go is it's a much more DIY friendly in that you can just go ahead and write your app without having to import some vast framework. And the whole thing about a framework, of course, is it saves you from having to write all of that stuff yourself, REST API and things like this. Which is great, but then as you and Chris were saying, you spend all your time debugging the framework instead of debugging your own code, which is much harder. And it's a bit the same with AI in that, now if you want some REST API server, whatever, you just say to ChatGPT, please write this, and then you argue with ChatGPT for another 3 or 4 hours until it understands exactly what you want. And then you just spend the rest of your time debugging that code that somebody else wrote. That's not a lot of fun for me. Oh yeah,
totally.
I think it's totally legit that some people, it's not a fun activity for them. They just need their problem solved with some software, and if it means they have to write it, okay, too bad. They'll grit their teeth and do it. AI is wonderful for people like that, I'm sure, because it's just like, great, now I don't have that difficult and annoying problem. I can just get the code done and go off and do something else. But for you and me and people who enjoy it as a fun activity, I think we'll continue to do that, right? And young people will too. If you're the kind of nerdy kid that I was that likes computers and so forth, you'll just want to play with them and do those things anyway, even if someone tells you you'll never make a living doing that. People still become poets and artists and dancers and things like that, don't they? Even though I'm sure their parents tell them they'll never make any money at it.
I would not really mind to not be being paid to write software, to be frank. I like that much, but I appreciate some money for sure. So, all right, that's a good segment to switch to our main topic for today. So, I have really enjoyed your book, and this is very true. I don't know how to say that better than that in English, but this is genuine. But I wonder, why did you choose the cryptography topic for this book?
Well, that's a great question. I mean, I've written a few books in the past for publishers where they approached me and said, you know, we really want someone to write a book that explains how to use Puppet or Kubernetes, you know, things that are notoriously hard to use. And I did that, but I thought it's not really what I want to write about. I want to write about programming, specifically Go, which is the language I enjoy programming in most. And so I thought, well, I can't just write about whatever I want, right? Whatever interests me. I have to keep one eye on something that's going to actually sell, because this is my living now. I don't have a job. I just sit here hoping that people buy my books. So please do, by the way. So I wrote a book for total beginners who've never done any programming of any kind or know anything about Go or computers. It's called For the Love of Go, just because I thought that's the book I would have wanted when I was first getting into it. Just something that doesn't assume any previous knowledge and just says, let's just do some stuff. And then I thought, okay, that's the book that introduces you to Go. I did some more on command line tools and testing and things like this. And then I thought, right, now I can write, I've got those commercially minded books on the shelf. Now I can write about something that I just think is interesting, whether or not anybody's actually going to buy it. I hope they do, but if they don't, it's not a disaster. And as a kid, I was obsessed with secret codes and spies. I'm sure a lot of kids are. Also trains and dinosaurs, but I haven't done books on those yet. But I'm still interested in secret codes and spies. And as you know, cryptography is actually everywhere in our lives, in banking, internet, software, computers, whatever. But it's just a black box, right? We don't really know what's going on. We just hear the word cryptography and it's like, fine, okay. I don't understand how any of that works, but I just hope that it does. I thought it would be a fun project to try and find out what is cryptography actually and what's it about. Not necessarily to teach you how to design your own ciphers or anything like that, because I don't know how to do that. But just how do actual ciphers work? What makes things secure or not secure? How are passwords stored? You know, that's a mystery. How does a blockchain work? What is a digital signature? How does that work? All of this stuff is really fun to find out about. So I really enjoyed researching it and writing about it.
Yeah, sure. And it shows in the book for sure. And I was wondering while I was reading your book, I mean, how much should they, quote unquote, a normal programmer should know about these things, you think? Is encryption should be more present in our day-to-day, I would guess, task and whatnot?
Yeah, that's a great point. I mean, I think you can get by as a normal person completely without knowing anything about cryptography. Of course, people do. As a programmer, I think you just use the code that's there. You know, in Go, you use the standard library crypto package, don't you? And it all just works, and that's great. But I think there's a little bit of a danger there in that, you know, for years and years and years, as a consultant programmer or whatever, whenever cryptography would come up in a discussion, I'd just sit there hoping no one asks me any searching questions about how it actually works, because I knew I wouldn't be able to tell them. You know, they said, oh, should we deprecate such and such insecure cipher suite? And they'd be like, oh, of course, as we all know, SHA-1 is insecure. And I'm just thinking, what is SHA-1 though? And why is it insecure? And what should we do instead? I really hope nobody asks me before I can Google this. So I thought, you know what, I'm going to sit down and just find out what's going on under the hood of this stuff. And I think that means learning to write some ciphers myself, like implement a cipher in Go, implement digital signatures, that kind of thing. Just not because I think that code would be any good, it's not, of course, but just so I understand it in my brain. And I think that's really valuable for other people as well, in that they won't have that cryptography imposter syndrome sitting in a meeting thinking, what the heck makes things secure or not anyway?
Yeah, I like that. I like that a lot, actually.
So I'm hoping people will read this book and not necessarily feel like, you know, okay, I could go ahead and write some new crypto system or something, because I don't think they need to. We have pretty good crypto systems already. The point is just that, I want people to feel confident that they understand the important principles, not the details necessarily. You don't need to know all the ins and outs of something like AES, for example. It's just helpful if you have a sense in your mind of what's vaguely going on.
Absolutely. Yeah, I needed to use AES lately in a project because and this is a subject that I want to keep for a little bit later. But suffice to say that one client of mine is storing kind of personal information in files and whatnot. I mean, those things should be encrypted. And like you said, even though we are using the crypto packages in Go, I mean, it's very, very interesting to have a little bit of background about how things work, and I appreciate that a lot.
Yeah, you're right. I mean, this stuff comes up all the time, doesn't it? I mean, even though we're not implementing ciphers, we are storing stuff, private data, or sensitive information. We're also using authentication, authorization, that kind of stuff. And it's super easy to get wrong, isn't it? And the consequences of getting it wrong could be quite bad. So I think it's really helpful if you have a sort of a gut feeling about how it works under the hood and why it's secure or not. I think that helps you use it more securely. And you could have the most secure crypto system in the world, but if you use it wrong, it's just no good, right? It's like if you have the world's safest car, but then you just drive it into a wall. It's a great example of this is, these come up all the time, but Zoom, for example, Zoom calls are encrypted, but it turned out that they were using AES, but they were using it in a mode that's known to be insecure, in ECB mode. And it doesn't matter what that is, I explain it in the book, but I also explain why is that so insecure, and let's go ahead and actually break it ourselves by writing some code to investigate that. And then say, how can we solve that problem, and what is a more secure mode for operating that cipher? It's all very well to just look that up on Stack Overflow, but I think it helps if you understand why you're doing things the way you're doing them.
Yeah, absolutely. When I read that part in the book, I told myself because you gave another example. And without spoiling too much, please go buy the book. But this piece needs to be told. I mean, if I recall correctly, some companies read some code, maybe on Stack Overflow and whatnot, and they kept the keys that were used in the article. And when I read this, I was like, oh my, this is incredible.
Yeah. They just didn't really understand what a key is. They're just like, it's just a long string of hex. So I guess this is fine, right? We'll just take it from this tutorial and use that. We're laughing, but it's unless you actually understand at some level what's going on. That for example, you need to keep the key secret. No good without that. It's, people are just sort of cargo culting a lot of this stuff, aren't they? Just copying and pasting. I'm sounding superior here, but that's exactly what I was doing for basically my entire life until I sat down and started learning about this stuff. So I think it was certainly valuable for me. I hope it will be for someone else.
Absolutely. And, confession for confession, I had to write, to wrote a kind of a shopping cart back. I think it was the first project I did when I completed my school, whatever. And I think it was in, 2000 or 1999 maybe, or 2000, let's say. So not much cryptography in that time, I would say. I was writing code in classic ASP at that. Mm-hmm. And to be frank, I needed to take credit card, and I did not want it. I knew behind my back that taking credit card and saving that in plain text was not good. Even though the majority of the companies were doing that back in those days, which is crazy to say today. So without really knowing what I was doing, I built a Delphi program, which was a desktop application, which allowed the person that was selling it was selling cigar back then. The site was like a1cubancigar.com. I don't think it exists. But the point is, the credit card was I was just replacing numbers with I don't remember, like 8 or 9. I mean, special characters, if you will, which was kind of the basic of hashing and whatnot. But I was not knowing what I had, like I don't know, 19 years old, 20 years old back then. Yeah. So I mean, when I hear what you are saying today, and yes, I think there's a lot of people that did that. But when I read that on your book, and knowing that we are still kind of doing errors like that today, it's kind of crazy. Which brings the question, John, is the internet not secured today? I mean, this is crazy.
Yeah, I mean, we have these incredible ciphers, mathematicians working away in basements, creating these amazing mathematical structures. And then people use some key from a tutorial, So yes and no is the answer. I mean, we have fantastic security technology available, especially in Go, real state-of-the-art stuff. And people, most people are probably using it okay, but there's occasional egregious slips, which are easy to make. That's the point, isn't it? It's not like people are being dumb because they don't know everything about this stuff. Practically nobody knows anything about this stuff, which is one reason I thought it's worth writing this book. I mean, one example is password rules, right? I'm sure you've encountered this on a website where you have to type in your password and they say, no, you can't use that password because it doesn't fit our rules. It's got to contain at least 3 digits, 2 special characters, 1 uppercase letter, and things like this. And I always thought that was dumb. But I didn't realize until I looked into it that these rules are actually making your password less secure. I mean, that's counterintuitive, right?
Yeah, this is incredible because after I read that, I never really thought about that this way. To be frank, I haven't put much thought. But once I read that, and I think it was probably 5 days later, I was on the website which was asking me, you know what, you should have 8 characters, 1, and I remember and I said, that's true. That's so true. I mean, they are giving the, the rules to crack password in plain English right there. It's crazy.
Yeah, I mean, a good way to illustrate this is suppose your password was just 1 character. And it could be any ASCII character, let's say. Well, you've got, if someone's trying to break into that by just guessing, they've got 256 possibilities. But now if you say your password has to contain at least 1 digit, well, there's only 10 possibilities, so that's way easier. The bad actor would be really grateful for a password rule like that because it drastically cuts their workload. And it's the same for longer passwords, of course. And I think that this is what helped me, is looking at the actual maths of it to see, if you have... Suppose you have a safe with a 1-digit combination. You just have to make 10 guesses in order to break into it. In fact, on average, you only have to guess 5 digits because you'll probably find it halfway through. But if you have 2 digits, it's 10 times 10. And if you have 3 digits, it's 10 times 10 times 10, and so forth. And if you keep timesing something by itself enough times, it gets pretty big pretty quickly. Which makes a really counterintuitive difference. Suppose you have your AES key, for example, is 255 bytes or 255 bits. You might think, well, how much extra security does adding 1 extra bit to it give you? A little bit extra, but not that much, surely. And the answer is it's twice as secure because, for all of the 255 bits they had to guess before, now they have to guess them all over again, but with a 1 instead of a 0.
Yeah.
So if you look at, for example, how long it takes to crack a password by brute force using sort of today's computers, I think it's something like, for a 7-character password, it's a couple of seconds. For a 14-character password, it's 100 billion years.
That's crazy. Yeah.
Quite a difference. So it's worth typing those extra characters. You know, if you are going to implement a password rule on your site, the best one you could do is just make it minimum 14 characters.
Yeah. Oh, yeah, totally. And not being a dictionary words and whatnot, I mean.
Yeah. Thanks for coming to my TED Talk.
So what, well, in that case, well, it seems like we are still in I don't know, a dangerous place even today. I don't know how to say that better, but what organization should do then to make sure that their security efforts is, I don't know, improving? And I mean, there's lots of smaller companies that just are not even there yet. So what do we do?
Yeah, that's a great question. I have no idea. Wish I knew. I mean, I don't have any expertise on this. I'm just someone who likes secret codes and spies. But I do think, you know, it makes sense to just avoid storing anything private or secret as much as you can, isn't it? Because then you just make an end run around the whole problem. It's like optimization, you know, best optimization is just not to do the thing. Store it in somebody else's service. Then you can sue them if it leaks. You know, store it in AWS, and then you can sue Amazon. You know, they've got the money.
Oh yeah.
Sure. But if you do have to store stuff, it's worth knowing a little bit about these things. For example, you know, one fun thing that I found out while writing the book was, you know, thinking about hashing algorithms. We understand hashing as sort of a way to take some arbitrary block of data and then just turn it into a number. Then you can compare two blocks of data quite easily to say, are they the same data, without having to actually send all the data. And that works for passwords too, but there's the special consideration wherein, you know, if we're hashing data for things like comparing if two files are the same, you obviously want that algorithm to be really fast.
Right.
And ideally hardware accelerated, and it usually is. But for passwords, I mean, hashing is also great for passwords because when I log in to some website, the browser can just send the hash of the password over the wire instead of sending the actual password. And then the bank can say, that doesn't match the hash I have, so, you know, no banking for you. But, you know, with passwords, you want your hash algorithm to be really slow. That's weird, right? Why would you want it to be slow? The answer is, you know, the only people who need to hash a lot of passwords quickly are the bad actors.
Right.
If I know the right password, I only need to hash it once. So that's fast. Even if it takes a second, I won't notice. Everything on the web takes at least 1 second. Whereas if I'm trying to hash 1 million passwords, the fact that it takes a second would be really annoying. It would really slow me down. So there are special hash algorithms just for passwords, things like scrypt and bcrypt. And you don't have to know how they work, and I don't know. But the point is, if you know they exist, you're like, aha, now I know which kind of hash algorithm to use for storing my password.
Yeah, totally. I believe that's why that's another plus for Go in my opinion, because all the crypto aspect is just easy to use in my opinion and my experience so far compared to other stack. I mean, I come from the .NET world. It's not that bad as well, to be frank, in .NET world, but I don't know. In Go, it just feels I would dare say even smooth to use those things.
Yeah. I mean, it's absolutely amazing because, you know, in the book I talk a bit about AES and just explain what's going on under the hood. Like, what does AES do to obscure? The plain text, the answer is it mishes and mashes those bytes around all over the place and combines them in elegant and impenetrable mathematical ways, which are very resistant to brute force and cryptanalysis and so on. And then when you look at the Go code in the standard library that implements that, which I recommend, it's fun to read, makes your head hurt a bit because there's a lot of bit flipping and twiddling, and it's very efficient because it's based on lookup tables and so forth. But it's still interesting, but a little bit complicated. But then what the Go code you actually have to write to use AES is so trivial. It's like 3 lines. And I almost felt bad putting the example in the book because I'm just like, this is literally copy and pasted from the docs. It's like AES.new cipher, plug the key in, then just encrypt your stuff. And it all just magically works.
Yeah.
I think that's terrific. And all you have to remember to do is not tell anyone the key.
Yeah, that's a special thing. So where are you putting your keys then? While we are on the subject.
Well, great question. I mean, the thing is, it's, as we've said, it doesn't matter if you've got the most secure crypto system in the world and the best code if your password is just password.
Yeah.
I mean, that's, or if you've written it down on a sticky note on your monitor. So the question is, how can you pick good passwords? And the answer would be they should be as random as possible. So obviously not in the dictionary, as you said. And like you, storing the credit card numbers, not much good just replacing letters with digits and so forth. That's easily brute force too. But it should be as random as possible. And we humans are not very good at being random, are we? It's really hard. The harder you try to be random, the more you aren't. And the best thing is just to use some random generator, the one on your computer. The problem with that is, how do you memorize a string of arbitrary binary digits, 256 of them? That's pretty hard, right?
A little bit.
So, of course, use password managers and things like this. That's what they're for, is precisely so that you can have long, complex passwords that you could never remember. And if they're stored in your password manager, you don't have to remember them, and you can't reveal them. Like, did you ever do this trick? I used to make all my passwords obscenities, so that if anybody asked me to tell them the password over the phone, I'd be too embarrassed.
Interesting.
And this does work until it's a customer or something, and then it's a little awkward. But password managers are fantastic until you find the author of the website has disabled the ability to paste into the password field. So again, probably meaning well, right? I don't know what they thought that would help, but
we do that for your protection. That's what they say.
yeah, exactly. So I think again it's just cargo culting. They probably just asked ChatGPT, what should I do to make my web app more secure? And ChatGPT said, insist on special characters in passwords and disable paste. But password managers are great. But if there's some password that you just have to remember, a great tip that I read is to think of some long phrase, some quotation that you like, or something from a poem or a TV show or something, and just use the initial letters of that phrase, something like that.
Yeah, good tip. And what about server architecture? So let's say there's multiple, I don't know, services out there, and they do need to encrypt some data. Do you trust the, I don't know, environment variable, for example? Where are you putting those keys?
Well, I think a lot of this is common sense, and most people have that, so they're not doing crazy stuff like storing passwords in plain text. And you can do that sort of stuff. But I think what's really important is just any code that you write is going to contain security bugs and all the other kinds of bugs as well. I don't mean you. I mean me too, and everybody. So just like with regular bugs, it's really important to get somebody else to look at it, because they'll be able to see, the error in huge font that you've been overlooking, that you've been staring at it for hours. And similarly with security, I think it's really worth, if your code is doing anything with security, get it reviewed by an actual sort of credentialed security expert, somebody who does this stuff for a living. There are people who just professionally find security holes in people's software and setups. And thank goodness, because apparently there's a lot of them to find. This is a booming industry, isn't it?
Yeah, absolutely. This is one of my questions. So do you think? Well, I've been noticing that for the last, I would say, I don't know, 5, 6, 7 years, companies tend to be more concerned about security. While compared to before there had to be a major critical issues in an industry before other companies in that same industry to start, I don't know, be concerned about security.
Yeah, I think it's a bit like, in a sense, the technology is not our friend here in that before frameworks and things existed, if you wanted to encipher something, you just had to invent a cipher and implement it yourself. And it would probably be terrible, but you'd be all right because nobody seriously wanted to know what your cipher was hiding. But it's now we have wonderful things like AES that you can just plug in and use. But if you don't understand how they work, you can accidentally use them insecurely, and that's really easy to do. So, as you say, we're all using cryptography and so forth a lot more and encrypted services all the time, but we don't understand how they work. So it's not surprising we're occasionally holding them wrong.
Yeah, I think we are starting to be better, though. I mean, I've been seeing a lot of movement in this, and maybe I'm a little bit biased because I had a small pass at Equifax for sometimes, and I was not there prior to their big fiasco. But I can assure you that for the little time I was there due to an acquisition, well, it seems to be pretty secure these days. But again, they needed some hit in the face. They needed something big to happen, and now in the crypt industry now, everyone started to pay attention. Oh, if they got caught, I mean, we haven't paid any attention to security for years.
Yeah,
I kind of see some huge demand for security experts as we advance in our society.
Yeah, I agree, and I think you're right that people are more aware of this stuff because there have been so many high-profile security breaches and leaks and things, and people are more aware of the importance of this stuff, and they're more sophisticated about how they go about securing things. And unfortunately, the bad guys are getting more sophisticated as well, right? They're probably buying my book too. I don't mind.
Sure. Unless they found some ways to abuse the system, if there is. So I mean, I can imagine that they are also getting better and better, which is kind of scary at the end of the day, because I mean, there's so much information out there. It's kind of, and again, I will return to that, but the examples that you gave on the book, when you don't really know, and I'm a little bit guilty of not really following news and whatnot. I don't know. It's not something that I'm very good at, but to know that those bigger organizations have such such bad practice even these days in security. I mean, I don't know. I start to ask myself, well, should I don't know, should I get everything I have on the internet and just secure that on my unplug the machine at some place and a hard drive and whatnot? I mean, this is scary.
Yeah, I mean, you also have to consider who is the adversary. Who is it that we're trying to protect this stuff from? And most people are pretty honest, so it's it's not like someone's probably going to be trying to crack the password on your computer and read your appointments or something. But things like foreign governments, espionage, military secrets, all of this kind of stuff, that actually does have some real consequences if that stuff's not secure. So the question, the thing is, we're in a fantastic place with cryptography now, in that we have systems like AES, which have no significant vulnerabilities that we know about. There are probably a few we don't know about, but we don't know about them, so that's all right. For example, I mean, back when you were storing your credit card numbers for your cigar company, we didn't have such great security technology available. We had things like DES, which I think was 56-bit key or something like that, something that would seem very small now. And part of the fun reason for that was, intelligence agencies did not want people using a more secure cipher than that, because then they wouldn't be able to read it. They like to make sure that they can read the encrypted stuff that everybody's sending around. That makes sense. All right, that's their job.
Sure.
But all you have to do is use AES with a 256-bit key, and not only will the government not be able to read it, but nobody else will either. And do a little back-of-the-envelope math in the book to work out, how much time and energy is involved in cracking a key, something like that. And I think I read somewhere that the average energy released in a typical supernova is something like enough to enumerate, 128 bits or something like that. So you'd need a good many supernovas to crack that AES key. In fact, you'd need about a galaxy's worth. So imagine some future civilization, which Kardashian Type 3 civilization, which controls the energy resources of an entire galaxy, and they can throw them all into cracking the password on my zip file. Must be something really interesting in there. But, they have to burn up a galaxy, basically, to break this encryption. And that's the encryption I'm using today in 2024. So I think that's pretty good. It's hard to think of some other area of technology in modern life that's as impressive as that, isn't it?
Absolutely. But it just needs to continue, I think, spreading a little bit more, because we tend to see that the adoption seems to be there, maybe on more bigger organization, but I still have clients that, I don't know, they don't really see the benefits still to inject some money in security. I mean, it's still not a super huge concern, and I understand that, but they could still have a lot of problem. Maybe not breach, but just ransomware, which is terrible for a small company. So I mean, yes, it still needs to spread. And to my defense, for my old credit card, I mean, I don't even believe that people were hashing credit card back then. So they were kind of storing that straight plain text in databases,
right?
Which was crazy.
One of the first jobs I ever had as quite a young person programming was working on a sales system for telesales, and people had to enter their credit card numbers. And as you know, credit card numbers have a check digit or digits. So you take the first X digits and you do some munging on them, and then they should match the last digit for parity or whatever, and you can tell if you typed it in wrong. So I read up this algorithm. This was before Google, but I found out how it works. And of course, the first thing we did was turn it around and use it to generate as many valid credit card numbers as we wanted. That's kids for you. And I'm sure we bought a lot of illicit cigars that way.
Nice.
But it's fun and interesting to know this stuff. And I think the same instinct that makes people want to break into their school computer network, as I did, and I'm sure you did, and quite a few other listeners, right? It's that same instinct. When you grow up, hopefully you become part of the white hat community, and you're interested in working out how to stop people doing that kind of stuff.
Absolutely.
It's the same parts of your brain lighting up in both cases, though, isn't it? I think. Yeah,
totally. I did appreciate, though, in your book the other way around. So you kind of make us create a simple encryption, and we build something to break it. This is nice. I will be frank. I'm not a huge. I don't know. I'm not a huge. Not fan. I'm very fan, but I'm not very knowledgeable of all of those things, and I never really. I don't know. I think I'm a white hat person, I would say, if you want to take that analogy. Never really tried anything crazy myself, but again, I found it interesting to build something to crack something that we build on the book. So.
Yeah, me too. And I once had, my boss had something in an encrypted Word document with the password on it, and he forgot the password. He said, "Is there anything you can do?" And I said, "Yeah, I can write a brute force password cracker. Let's do this." Let's wield the awesome power of Perl or whatever.
Did it work?
Yeah, totally.
Oh.
I mean, he was delighted, but on the other hand, also a little worried. He said, "Well, if it's that easy," I said, "No, but you have to be a genius to write that program."
Nice.
I'm sure he still believes that.
The good old days.
Yeah.
Cool.
But yeah, it's really interesting and fun, and that's the point. Is I think if you're a professional developer and you work with security and authentication and stuff, as I'm sure you do, then I think this book will be valuable to you. But even if but also, and even if you're not, I think it's just cool.
Absolutely. Oh yeah, yeah. I think everybody should gain from reading the book for sure, because yes, I mean a basic knowledge is really great, and yeah, I think for me it was surprising how I was discovering things that I'm using every day, and I said, wow, this is interesting. The padding function, for example, that was one very interesting to me. When you have a key, let's say a 30-bit key that is not filled completely, what do you do with the remaining bits? And I was like, I don't know. I don't know.
Exactly. It's just these questions never even occurred to me before, and I'm slightly surprised to realize I don't know how to answer them. But it turns out, you can design a padding scheme which is very elegant and simple to write. It's just a few lines of Go. It works perfectly. And I didn't invent it, of course, just looked it up. But that's really interesting. And I think, let's normalize reading about stuff that's just interesting and fun, and writing programs that are interesting and fun, just for the sheer mental joy of it. I think that's allowed, isn't it?
Oh, yeah.
Should be allowed.
Should be. And to me, at least, I'm now very interested to go a little bit... dive a little bit inside the Go packages and things like that. So, like you said, AES might be interesting. Not. Of course, I will not grasp anything and things like that. But just my curiosity. Now I am curious about cryptography, which I was not really before reading the book. Which is crazy, because I like the secrets. I like the things that you were mentioning, but I don't know. It never really occurred. I've been building too many small businesses in my career so far. So I mean, it was taking way too much of my time, I think.
Yeah, I'm glad you said that. I hope it inspires a few other people to be interested and to learn more about this stuff. For example, to learn about actual cryptanalysis and how to design ciphers and things like that, so that then they can explain it to me.
Sure. All right. So cool. So. All right, I think we can wrap up with a closing comment. So I like to ask people if there's anything that they are missing in Go. So maybe you talked about Perl a couple of minutes ago. I mean, is there anything that? And I understand that Go is simple, and we all love the simplicity and things like that. I really like Go as it is, but let's just, I don't know. Let's just talk for a minute. Do you miss something?
Well, I've used lots of different programming languages over the years, and I think Go is one of my favorites, precisely because almost everything is already missing from it.
Yeah,
it's. I mean, when you're young and getting into this stuff, and you like expressing yourself in beautiful, elegant code structures, there are languages that are optimal for that, where you can create almost any kind of construct you want, and programming it any way you want. You like object orientation, program that way. You like functional programming, do it that way. Great. You can do whatever. Go is definitely not like that. Go is more like, this is the way you do it. If you don't like Go's way, probably find some other language. But that's okay. I appreciate that now. I'm a bit older and got a slightly more pragmatic view of these things, especially because I teach it for a living. It's very simple, less for me to teach. Easy money, right? And to actually answer your question, I don't find myself writing Go programs and thinking, if only I had this keyword, this would just instantly solve my problem. I mean, I know people do think that, and they make regular proposals on the Go issue tracker. Please just add this one keyword and it'll solve all my problems. They don't realize, of course, it will create 100 more. But never mind. I think one thing that really bugged me for a while was, let's say I have some function adds two numbers together, and I say func add x and y int, returns int. Okay, what if they're float 64s though?
Mm-hmm.
Or what if they're uints? Or what if they're int 64s? Do I have to write a separate function for each of those? Like for every numeric type, I have to write another function with a different signature. And the answer is yes, that's just the way it is. But you can use code generation. Oh, great. you know, now I have even more problems because I don't understand how my code generation works. And I thought, that's crazy. Shouldn't it be possible to just write some function add of t any, you know, or t some set of numeric types where I can just add them together? And, you know, it turns out they've already added that.
Yeah. So you're a fan of generics after all?
Yeah, or rather, I think that was the only thing which tripped me up and thinking, this is weird. Isn't there a better way to do this? Don't let me down, Go. Yeah. You know, surely there's some sensible way to do this with not too much typing. And they do now have that. So that's a shame because now I have no good answer to your question. But
well, it's pretty good. This is interesting because I was exactly like you about generics, and I find myself not really using them once they are there. I don't know what's wrong with me.
No, there's nothing wrong with you, and I think everybody feels the same.
Okay.
I wrote another book specifically about this just to tell people how cool I think generics are, and that they're not nearly as complicated as you might think or fear or as it sounds. And one of the quotes I use in there is from somebody who said generics is an incredibly interesting and useful addition to the language that I'll probably never use. And I thought he's absolutely right. I mean, it is super cool when you see what they've done and how they've done it. It's so Go-like, just the absolute minimal extra syntax, but it opens up a whole new world of different ways of programming, you know, functional programming, map, reduce, filter, all of that kind of thing. Right. Generic types and collections, absolutely wonderful. But I think people largely don't know about it. It's just, you know, they didn't get the memo or whatever. And you still see people complaining on Twitter that Go doesn't have generics. You're kind of like, I have news. And they say, oh, but it took them too long to add it or whatever, so I'm still against Go. Never mind. I'm not going to like Go no matter what they add to it. But I think people who have heard of generics just think that sounds like something complicated that's not for me. You know, that's for experts, right? Senior developers, whoever they are. But I think it's something that's interesting and fun and quite easy. So I wrote the book just to say, here's some cool stuff we can do with generics. It's called No-Go Generics.
Nice. Oh yeah, totally. It's very nice that they are there. I use them a couple of times. To be frank, it's just that I don't know. It feels like sometimes even though the readability is good, I still sometimes prefer to I don't know, to use the good old way.
Yeah, well, the thing is, it's not so much that we want to write generic functions, although that's nice. I mean, unless you're writing some kind of general purpose library for people, you don't need to write an add function that takes any numeric type or whatever. You just add the types that you have, right? If you have a couple of int64s, you can just add those together, no problem. No need to be generic. But it's kind of nice to be able to write generic types, a slice of T, you know, of some type T, especially if you're writing something like a cache or some kind of store or key value store or something. You can just really easily make it generic. But the super nice thing is the APIs that it enables for regular users like you and me, just want to use the standard library. You know, again, think about the math package. You know, everything's float64. So if you wanted to do min of two numbers, you have to cast them to float64 first. That's really annoying. Why do I have to do that just to know if 2 is less than 3? Because we now have min and max built in. That's great. But they can now build a whole load of totally generic APIs in the standard library, which solves a lot of that problem, takes away some of the boilerplate, and also enables some really cool new language features which just would have been impossible to do without them, such as iterators.
Yep.
Iterators are super neat. And in fact, in the second edition of No-Go Generics, I added a section on iterators, even though they're not in yet.
It's coming.
Still just a proposal, an experiment, right? The range over func experiment.
Yeah.
But it's so neat, I just can't stop talking about it.
Oh yeah, I'm with you with that. It's very interesting, John. Maybe we should schedule another call at some point. Really appreciate your topics and whatnot.
Sure, that'd be great.
Cool. So is there anything that I missed? Do you have something that you want to say to listener? Obviously, we will have all the links in the show notes. But I mean, it's the time to say a last thought or something like that.
I don't think so. I think I've said it all at great length, and thanks for your patience in listening to it.
Thank you very much. All right, that's it for this week. I would really appreciate if you can talk or share about this podcast. It's always helpful. Also, another way to support this show is by purchasing my course. There's always a link in the show notes. So on that, see you next week.